Recovery of aluminium metal from bauxite. Aluminium is a very useful metal and has several applications due to its lightweight and strength. South Africa produces aluminium using an electrolytic process. The ore of aluminium is bauxite, which is not available in South Africa and is imported from Australia. Bauxite is impure aluminium oxide, Al2O3. Bauxite is not directly used in the electrolytic cell, but is first converted to alumina through mineral processing. This pure aluminium oxide is converted to pure aluminium metal in an electrolytic cell through the Hall-Héroult process. Let us draw the schematic diagram of the electrolytic cell used in this process. The cell is lined with steel on the inside, which serves as the cathode. Carbon electrodes are lowered into the cell and act as the anodes. The electrolyte is not an aqueous solution, but rather molten alumina. In fact, alumina has a high melting point of about 2000 degrees Celsius, and therefore it is dissolved in cryolite, which lowers the melting point to 1000 degrees Celsius. The electrolyte needs to be kept molten throughout the process. When the electrodes are connected to a DC power supply, there are electrochemical reactions that take place at the cathode and at the anode. Al3 plus 3 electrons giving Al liquid, reduction at cathode. 2O2 minus giving O2 gas plus 4 electrons, oxidation at anode. Liquid aluminium is formed at the cathode, while oxygen gas is formed at the anode. The overall reaction can be written 4Al3 plus 6O2 minus, giving 4Al liquid plus 3O2 gas. Note that the ions in this reaction are not aqueous ions. At the anode, the oxygen gas undergoes a reaction, since it is in contact with the carbon electrodes. C solid plus O2 gas, giving CO2 gas. The carbon dioxide gas bubbles leave the cell from the top. This reaction depletes the carbon anodes, and they need to be replaced regularly. This electrolytic process uses a massive amount of electricity and is extremely expensive to produce aluminium metal through this process. This has several environmental consequences, such as depletion of coal reserves, acid rain, and global warming. Carbon dioxide that is produced at the anode adds to the problem of global warming. Also, cryolite used in this process breaks down and produces emissions that are harmful to human health.
Starting to feel it? Now go master it with Maski.